faham sangat. Okay, hari Jumaat pula tu. Okay, dah tengah puasa kan. Okay, lepas tu kena masuk kelas teori pula. Okay, tapi tak apa, jangan tidur lah Okay, so harapnya yang tidur. So nanti saya akan buatlah quiz, pop quiz terkejut-terkejut sementara saya bercakap ni. Okay, so harapnya kita sama-sama lah bertabah sampai ke akhir kelas ni Okay, so hari ni kita buat kelas awal sikit So nanti sekarang bolehlah kita habis awal sikit. Nanti kau ada yang nak pergi meniaga bazar Ramadan ke kan. Okay. So bolehlah habis kelas awal sikit. Okay Boleh semua? Kita mula kelas kita.
Boleh madam, boleh.
Boleh madam, boleh.
Boleh madam. Boleh.
Okay, terima kasih. Okay, so kita akan mulakan. Okay, so basically apa yang kita akan tengok for today's class. Dia ada benda yang saya pernah cakap lah dekat dalam kita punya practical class sebelum ni, which is in our practical class previously I'm talking about the galvanic cell. Okay, so you already set up the galvanic cell. Okay, you already done with the cell potential. Okay, so in the previous practical class I also explain how to do the calculation to find out the cell potential, right? Okay, so macam kelas ni macam ulangan saja untuk enhance awak punya pemahaman, dan ada beberapa lah knowledge barulah yang kita akan tengok. Okay, and then kita akan try out with the example juga. Okay, so saya akan tunjukkan beberapa contoh soalan yang kita boleh tengok lah. Okay, so for today's class, the lesson learning outcome for today's class is to categorize strong, weak and also non-electrolytes. Okay, so we are going to categorize the electrolytes. Okay, so the liquid form ataupun the aqueous form of conductor of an electricity that you have in you punya cell tu, whether electrolysis or galvanic. So we are going to take a look on the characterization of a strong, weak and electrolyte. So how we categorize this electrolyte as strong, weak and also non-electrolyte. And then after that we are going to describe an electrochemical cell, or the galvanic cell or the voltaic cell. So describe the electrochemical cell by its reaction. So what are the reaction taking place? Using an equation. So the voltage produce balance redox equation, and also the electrical potential. So these are the one yang kita dah tengok lah sebelum ni. Previously in our practical class, I already shown you the table of the standard reduction potential. And then we do the calculation according to the formula to find out the cell potential. So these are the things yang kita akan tengok balik sajalah. So first of all, what are electrolytes? So electrolytes are chemicals that breaks into ions, ionized when they are dissolved in water or in aqueous solution. So the positively charged ion are called cations, and the negatively charged ion are called anions. So positive charge element, for example, Cu2 plus, Mg2 plus, so that are cation. And then negatively charged ion, for example, nitrate ion, and O3 minus is called anion. So the substance can be categorized as strong, weak and also non-electrolyte. So when the compound dissolve in aqueous solution, it dissociate into an ion. So whether cation or an ion. So these are the things yang akan conduct the electricity lah. So strong electrolyte is completely ionized in water, or in aqueous solution. So same goes with the one that we already learned in previous acid and base chapter. So when you have concept dia lebih kurang sama lah. When you have strong acid, for example, it is going to ionize 100%, right? In aqueous solution. When you have strong electrolyte, also same lah. So the compound is going to be completely ionized in aqueous solution. So this means 100% of the dissolved chemical breaks into cations and also anions. So the example of strong electrolyte that we can tell is strong acid, strong base and salt. So they are strong electrolyte. So that means it dissociate 100% in aqueous solution. So ionize 100% in aqueous solution. So for the weak electrolyte, is partially ionized in water, or in aqueous solution. So any dissociation into ion between 0% to 100% makes a chemical weak electrolyte. But in practice, around 1% to 10% of weak electrolytes breaks into ion. So basically, for the weak acid, so untuk weak acid ni, weak electrolytes, dia sama juga macam weak acid that we learned previously and acid base chapter. So for example, for the weak acid, okay, the dissociation is so small, okay. So partial saja ataupun sangat sikit. Okay, so that's why when we are doing the calculation previously in acid and base, okay, kita boleh just omit or just abaikan, okay. So the concentration of ion that dissociate tu. Okay, so 1 to 10% saja, okay, yang akan breaks into an ion. Okay, so weak acid and weak base are weak electrolytes. So most nitrogen containing molecule are weak electrolytes. Okay, so water is also considered as a weak electrolyte. So later on, I'm going to show you, okay, the list of example lah for strong, weak and also non-electrolyte. Okay. So for the non-electrolytes, okay, it's a substance that doesn't ionize in water at all. So it is a non-electrolyte. Okay. So for basically for the non-electrolyte, so there are compounds that dissolve in aqueous solution, but it is not going to form any ion. Dia tak akan ada membentuk apa-apa ion lah, positive atau negative charge ion lah, cation or anion. Okay. So that compound yang non-electrolyte ni dia boleh dissolve in aqueous solution, boleh dissolve in water, okay, tapi dia takkan ada ion, dia tak ada ion, free moving ion tu. Okay, because in galvanic cell, in electrochemistry, in electrolysis, okay, we need that free moving ion to conduct the electricity. Okay, so kalau that compound is a non-electrolyte, maknanya that compound tu tak boleh nak conduct electricity lah. Okay. So most carbon compounds are non-electrolytes. Okay, fat, sugars and alcohol are largely non-electrolyte. For example, sugars. Okay, gula yang you guna kat rumah tu, okay, kita larutkan, kalau kita larutkan dalam air, yes, it can dissolve in aqueous solution, it can dissolve in water. But there is no ion formation. Okay, so maksudnya dia still tak boleh nak conduct electricity lah. Kalau kita larutkan dia pun, okay, cairkan dia pun, dia tak boleh conduct electricity. Okay, sebab dia tak ada free moving ion. Okay, so kalau macam dekat weak electrolyte ni tadi, dia kata water is considered as a weak electrolyte. Okay, so water is considered as a weak electrolyte. So dekat dalam you punya experiment of electrolysis sebelum ni, okay, so you are doing the electrolysis of water. Okay, so pada siapa-siapa yang buat ataupun dah tengok video dia tu, okay, at first, okay, dia memang adalah, okay, dia bolehlah conduct the electricity tu, okay, tapi tak banyak sangat lah, okay. But once you dah adding NaCl, okay, so nanti you akan tengok, okay, lebih banyak formation of bubble form at the electrode. Okay, so sebab apa? Okay, so kalau kita tengok dekat sini, okay, strong electrolyte, okay, also termasuk dengan salts juga. NaCl is considered as a strong electrolyte. So that's why water is a weak electrolyte. Okay, so water weak electrolyte, okay, bolehlah can conduct electricity, have a free moving ion, okay, but not as much as a strong electrolyte. Still you can observe the chemical reaction, okay, but not as much as when you are adding sodium chloride, okay, to you punya electrolysis cell. Okay, so sebab, okay, NaCl ni bila you tambahkan dia, dia akan bagi lagi banyak free moving ion. So maksudnya tindak balas tu akan berlaku lebih pantas lah. So you're going to see the rapid movement ataupun the rapid formation of bubbles form at both electrode. Okay, so compared to the previous experiment when you did not adding water into the solution ataupun into you punya electrolyte. Okay, so these are the table of strong electrolyte, weak electrolyte and also non-electrolyte. Okay, summarize the group of strong, weak and also non lah. Okay, beberapa contoh dia lah. Okay, okay, so that is for the strong electrolyte, weak and also non-electrolyte. Okay, so do you have any question before we move to the galvanic cell?
No, madam.
No, madam.
Okay, so next we move on to the galvanic cell. Okay, so for the galvanic cell, previously dekat dalam you punya experiment, okay, so you already done with the setup of a galvanic cell. But first of all, before we proceed, okay, with the calculation, with the setup of the cell and so on, okay, so we are going to take a look on the history of the galvanic cell first lah, okay. So the idea, okay, so maksudnya galvanic cell ni adalah a basic formation ataupun basic concept untuk kita hasilkan tenaga elektrik. Okay, so for us to make a simple power supply. Okay, so simple power supply. So kita gabungkan this metal and this metal, electrode, electrolyte, wire and also dia punya salt bridge tu. Okay, and then kita dapat form satu sel yang menghasilkan tenaga elektrik. Okay, so that is the concept of the galvanic cell. So the first macam kita katakan person ataupun scientist lah, okay, that come up with the idea. So macam mana kita boleh hasilkan tenaga elektrik ni, okay, is Luigi Galvani. Okay, so kita tengok sikit lah, okay, what are the experiment, okay, what is the experiment that Luigi Galvani, okay, done, okay, to detect, okay, there is a presence of electrical charge tu. So Luigi Galvani discovered when copper and zinc were connected together and then both touched to different parts of the nerve of a frog leg at the same time, okay, they make the leg contract. Okay, so frog ni dah mati lah. Okay, and then what Luigi Galvani do is dia ada metal yang berbeza, zinc and copper. Maksudnya dua ni keupayaan dia berbeza. Okay, so bila dia connectkan pada nerve of a frog leg, okay, maksudnya dekat badan yang dia dah bedah tu lah. Okay, so katak yang dah mati ni dia punya apa tu, kaki tu bergerak-gerak. Contract lah, ada contraction lah. So that means dia kata mesti ada something lah, okay, yang menyebabkan terjadinya contraction tu. Okay, so maksudnya akan ada macam kena renjatan lah. Okay, macam kena renjatan. Okay, so kita tengok sikit, okay, dia punya experiment of the Galvani ni. Sekejap
depuis peu de
Okay, dia punya apa tu, suara tak payah dengar lah. Dia cakap Italian ke Spanish ke apa, saya tak tahu. Okay, kita tengok je apa yang dia buat tu lah. So that is how lah, macam mana dia buat tu lah. Okay, eksperimen tu. Okay, so sikit je. Okay, so macam tu lah, okay, rupa dia eksperimen yang Luigi Galvani buat hari tu, dulu tu. Okay, yang dia get the idea, okay, macam mana tenaga elektrik tu boleh terhasil. Okay, so cumanya macam at this point Luigi Galvani fikir yang maksudnya kita boleh jana tenaga elektrik daripada animal. Okay, so tapi idea Luigi Galvani tu dah dikembangkan. Okay, so dah dikembangkan oleh Alessandro Volta. Okay, so for the Alessandro Volta ni dia dah fikir, it's not actually the electrical charge to form from datang daripada animal tu boleh menghasilkan tenaga elektrik, tapi ada komponen-komponen yang ada dekat dalam tu lah. Maksudnya ada moisture, okay, maksudnya ada liquid, okay, yang bertindak balas dengan metal-metal yang digunakan tu, okay, untuk menghasilkan tenaga elektrik. So maksudnya dia dah kembangkan idea that yang Luigi Galvani dapat tu lah. Okay, and then daripada Alessandro Volta ni lah juga, okay, kita dapat the unit of the voltage tu, okay, which is volt, right? Okay, so from the Alessandro Volta lah. So that is a little bit, okay, history about the galvanic cell. Okay, so basically for the galvanic cell, so these are the arrangement. Okay, so ni adalah dia punya arrangement of galvanic cell itself. Okay, so ni adalah susunan dia. Okay, so ni yang kita dah buat juga dekat dalam lab previously. Okay, so common example of a galvanic cell. Okay, so you have salt bridge. Okay, you have electrode. Okay, two kind of electrode. Okay, yang mana satu akan berperanan as an anode, another one will be a cathode. Okay, so you ada salt bridge. Okay, each part is called half cell. Okay, so separuh daripada ini, sekejap saya nak kena share screen. Okay, boleh nampak tak saya punya screen sekarang? Saya
Boleh,
share screen.
Boleh, madam.
Okay, so this is a half cell. Ni separuh sel lagi lah. Okay, so each cell ada electrode. Okay, so ada zinc and also ada copper. Okay, and then yang liquid ni is considered as an electrolyte lah. So this one has two half cell. Copper metal is a solution of copper ion and zinc metal is in a solution of zinc ion. So these are the thing yang kita dah tengok juga previously in our practical class. Okay, so if you have an electrode copper, okay, so you punya electrolyte mestilah datang daripada ion copper tu sendiri. Okay, so whether copper sulfate, sulfate, whether copper nitrate, okay, so biasanya nitrate atau sulfate lah. Okay, so same goes with this part jugalah. This ada half cell juga. Okay. Okay, so saya tukar ni slide. Sekarang, so part of the voltaic or galvanic cell, okay. So ni yang sama, okay, ni ada juga saya tunjuk contoh sebelum ni, okay. So you have a voltmeter, okay, to measure the voltage produced when you have two half cell ini, okay. So basically ada juga voltmeter, sometimes juga dia akan connectkan pula dengan kadang-kadang dengan bulb, okay, lampu. Okay, so maksudnya kalau lampu tu menyala, okay, so that means there will be a formation ataupun there will be an electrical charge lah, electrical current produced lah, okay. So voltmeter to measure the voltage produced or the maximum potential value of two different half cell ni, okay. So you have wire to complete the circuit, okay. So anode, okay, where the oxidation occur, okay, and then flow of an electron always from anode to cathode, okay. So salt bridge, okay, a device to maintain an electrical neutrality in a galvanic cell. So how dia maintain the electrical neutrality tu, okay, dengan membolehkan, okay, so the ion-ion present, okay, move to the dedicated electrode. For example, okay, so Ag plus is a cation, so dia akan move pada cathode. Nitrate is an anion which is nitrate form from the ionization, okay, of kita punya electrolyte ni lah. Okay, so nitrate is an anion, okay, will go pass through the salt bridge, okay, and it's going to move to the anion. Okay, so copper 2 plus is a cation, okay, so dia perlu, okay, dia perlu bertukar ataupun perlu melalui salt bridge ni untuk pergi kepada cathode, okay. So maksudnya when there is no salt bridge ni, kalau tak ada salt bridge ni, okay, this electrical circuit takkan complete lah sebab ion ni tak boleh nak pergi. So macam mana ni ada bekas, tak ada ion ni, dia tak ada kaki nak panjat, nak turun beaker ni, pergi panjat pula beaker ni. So kita perlukan salt bridge lah to complete the electrical circuit lah, okay, nak maintain electrical neutrality by facilitate the movement of ion produced tu, okay. And then the electrode, okay, where the reduction occurs, okay. So flow of an electron always from anode to cathode, okay. So ni simple je, maksudnya mudah je ni, okay, untuk kita faham. Okay, so the diagram to the right illustrate what really happens when galvanic constructed from zinc and copper to sulfate, okay, using the respective metal as an electrode. Okay, so these are the chemical reaction happen. So as we know that, okay, galvanic cell ni is a spontaneous reaction. Spontaneous reaction. So maksudnya dia convertkan, okay, energy tu from chemical energy convert kepada electrical energy. Okay, so dia convertkan chemical energy kepada electrical energy. Chemical energy dekat mana? So the chemical reaction yang berlaku dekat dalam ni, okay, so ada part yang akan release elektron, ada part yang akan gain elektron, okay. So ni release, ni gain, okay. So all the chemical reaction yang berlaku ni, okay, akan menukarkan, okay, akan ditukarkan to the electrical energy, okay, tenaga elektrik, okay. And then dapatlah measure what is the electrical energy produced from the chemical reaction, okay. So as we can see, okay, from here, okay, so apa yang kita boleh baca from this diagram, okay, so anode is going to release an electron. So as you can see, okay, releasing an electron, okay. So the zinc metal ni, okay, so akan release, bila dia release electron, dia akan keluar as zinc 2 plus. Okay. And then zinc 2 plus yang ada dekat dalam solution ni jugalah. Okay. So after a period of time, the anode may appear to become smaller as it falls into a solution. Okay. So daripada zinc solid ni, okay, dia akan jadi zinc 2 plus tambah 2 elektron. So 2 elektron ni akan ditransport ataupun akan dibawa, okay, will be transported, okay, through the electrical circuit atau wire ni, okay, towards cathode electrode. So this cathode electrode ni, okay, so 2 elektron ni tadi akan digain pula. Okay, so 2 elektron ni akan masuk kat dalam ni. Okay, so copper 2 plus, okay, daripada this one lah, okay, from the solution, okay, so akan pergi kepada electrode, okay, and after period of time it may appear larger due to ions from solution plating on it. Okay, so ion from a solution. Okay, so kalau kita tengok yang ni, for example copper 2SO4 lah, okay, CuSO4 lah, okay. Okay, copper 2 sulfate, okay. So daripada mana datangnya Cu2 plus ni? Datang daripada dissociation of copper 2 sulfate as an electrolyte pula. Okay, so ion from solution ni akan plating dekat electrode. So that's why, okay, at the end, okay, after a period of time, dekat bahagian cathode ni akan nampak lebih tebal ataupun ada benda yang menempel dekat situ lah, okay, plating onto it, okay. So that is the chemical reaction occurs dekat dalam galvanic cell ni lah, okay. Okay, so comparing galvanic and also electrolytic, okay. So for the voltaic cell, okay, or galvanic cell, okay, spontaneous reaction, okay. So macam tadi lah saya cakap, okay, spontaneous reaction kenapa? Because it change chemical energy into an electrical energy, okay. So for the electrolytic cell is a non-spontaneous. Sebab apa? Okay, masa you buat electrolysis tu, so you need a power supply. Okay, so you ada bateri, okay, you ada bateri yang 9 volt tu, okay. 9 volt tu you sambung dekat punya wire beaker yang ada pensel tu, okay. And then to make sure that it's tengok ada bubble form dekat situ. So maksudnya you convertkan electrical energy, okay, to the chemical energy, okay. So kalau tak ada power supply, tak berlakulah chemical changes dekat sini. Okay, so this is considered as a non-spontaneous reaction. Okay, so for the standard cell potential, okay, because it is a non-spontaneous reaction, so that means it is going to produce voltage. Okay, dia menghasilkan voltan. Okay, so dia menghasilkan tenaga elektrik lah. So value of the standard cell potential bila kita buat pengiraan tu must be in a positive value. Okay, so for the electrolytic cell, because it is a non-spontaneous reaction, so maksudnya dia consume that electrical energy, so it is a positive value. Okay, so basically for cathode and also anode, okay, both in voltaic, okay, or galvanic and also in electrolysis, okay, dua-dua sama je lah, okay. Cathode is going to undergo reduction in electrolytic and also galvanic, okay. Anode is going to undergo oxidation, okay. Same goes with electrolytic cell, okay. So if the electron undergo reduction, it is going to become strong reducing oxidizing agent. If the electrode undergo oxidation, it is going to become strong reducing agent, okay. So dia terbalik lah, okay. Okay, so cumanya dekat sini, okay, ada perbezaan, okay, in terms of the terminal, okay. So terminal lah, basically kalau dekat power supply tu, dekat bateri, okay, dia akan tunjuk, okay, positif ataupun negatif terminal lah, okay. Ataupun wire juga, okay. Kalau wire tu hitam dengan merah tu, okay, will represent a different terminal lah, okay, biasanya, okay. But for voltaic and electrolytic, okay, dia akan connect pada different terminal kalau you tengok dekat sini. Okay. So for cathode, okay, in voltaic, it is located at the positive electrode. Okay. For cathode, okay, in electrolytic, dia duduk dekat negative electrode, cathode dia. Okay. So anode, okay, negative electrode for voltaic, okay, and positive electrode for electrolytic. Okay. So dia nampak macam okay, tukar je lah, okay, dia akan bertukar, okay. But Later on, okay, supaya you tak confuse, okay, ini hanyalah label yang you ada dekat you punya power supply. Okay, ataupun dekat voltmeter. Voltmeter pun sometimes dia ada perbezaan warna lah to indicate the positive and also negative terminal tu. Okay, so because kalau you fikir lagi nanti you akan keliru lah, sebabnya because dekat sini when for the direction of ion movement, anion will go to anode, cation will go to cathode. So same goes with the electrolytic cell. Okay, so kalau kita fikir positive, negative terminal tu is a charge, okay, dia akan jadi masalah kat sini. Okay, anion, okay, contohnya dekat sini okay, anion, okay, anion is a negative charge element, right? Okay, dia akan pergi kepada anode. Anode akan duduk dekat negative electrode kat sini. Okay, so kalau kita fikir negative electrode ataupun negative terminal tu is a charge, dia akan takkanlah negatif nak pergi negatif balik. Okay, boleh ke? Okay, biasanya negatif akan pergi positif. Okay, so just think okay, the positive or negative electron ataupun terminal tu as a label saja. Dia label saja. Okay, untuk kita bezakan positif and negativity. It's not a charge. Kalau charge, you akan jam kat sini. Okay, nanti you confuse lah kat sini. Okay, so for the direction of electron movement, always okay, from anode to cathode. Because macam tadi, okay, so let's say macam tadi, okay, dekat anode, dekat zinc ni will produce 2 electron. And then the electron will travel through the wire, okay, and go to cathode, okay, and this cathode is going to gain the 2 electron that produced from this anode lah, okay. So dia tak boleh, dah ambil dah ni, dah masuk dah dalam ni, tindak balas dah selesai dah, okay, dia dah datang, electron dah come to this electron, okay, and then the ion from the solution dah plating into this electron, okay, and then dia tak boleh lah nak pergi balik, patah balik pula, bagi balik dia punya electron pergi balik ke anode, okay, so dia dah stop sampai situ saja, okay, so movement of an electron tu satu hala sajalah maksudnya, okay, dia tak ada dah datang dekat cathode bagi balik, dia tak ada reversible reaction for an electron, okay. Okay, so okay, kita cuba kat sini, okay, saya tunjuk contoh lah, okay. Sekejap okay, so dia kata consider the reaction below. Sekejap. Padam dia ni. Bagi ruang. Okay, so write oxidation, okay. Oxidation, reduction, half equation lah, half reaction. Okay, so kita akan asingkan dulu, okay. So apa yang ada ni, maksudnya Sn and Sn2 plus will be satu elemen yang sama, Sn2 plus, okay, and then Pb, okay, and Pb, Pb2 plus and Pb2 plus, okay, and Pb, okay. So Sn ni is solid, okay, and then maksudnya bila sekarang ni, okay, kita nak balance the chemical equation, kita tengok dekat sini mana kita nak tambahkan elektron tu, okay. So where we are going to place an electron, so kita tengok kat sini lah. So for cesium solid ni, charge dia 0, cesium 2 plus charge dia positive 2. So kita nak get one equal number to make sure the charge is balanced, okay. So how to get an equal number? We are adding an electron. Okay, so for example, we want to balance it ataupun kita nak make sure, okay, it has the same value for reactant and also product, okay, as 0 for example. Nak samakan dia kosong dengan kosong. Okay, tak nak samakan dia dengan 2. Okay, so kita nak tambah lah, kita nak jadikan sebelah ni kosong, ni tak payah buat apa. Nak jadikan sini kosong, kita nak kena tambah elektron. Okay, so 1 elektron akan bernilai negatif 1 lah. Okay, so kita tambahkan dekat sini 2 elektron. So kalau tambah 2 elektron, this one negative 2, so that means it equal to 0. Okay, so dekat sini, okay, kita tahulah kat sini, okay, kat sini oxidation. Kenapa? Okay, kalau kita tengok elektron produce at the product side. So that means it is going to release an electron. Okay. Ataupun lagi satu, macam mana nak tahu from half cell ni ataupun daripada persamaan ni, okay, which compound yang akan undergo chemical equation, which compound yang akan undergo oxidation or which compound yang akan undergo reduction. So kalau kita tengok SN ni kosong kat sini. Okay. And then at the end oxidation number dia ataupun charge dia jadi positif 2. Dia punya oxidation number bertambah. So maksudnya dia akan undergo oxidation. Okay. Kalau yang Pb2 plus ni daripada positif 2 dia akan jadi kosong. So oxidation number dia berkurang, dia akan undergo reduction. Okay. So yang ini yang kita dah tengok dalam previous eksperimen kita lah. Okay. Okay, so itu untuk satu. Okay, selesai dah satu half equation. Okay, kat sini sama juga. Positif 2, kosong. So kita tambahkan 2 elektron supaya dekat sini jadi negatif 2, kosong, kosong. Okay, so ni considered as a reduction lah because the electron is going to be begin, okay, by the reactant. Okay, so ni akan undergo reduction. So now, okay, kita nak complete the balance equation. Okay. So complete balance equation kita akan combinekan balik dia lah. Okay. So kalau dalam ni tak ada apa-apa, tak ada masalah. Okay. Because 2 electron release and 2 electron gain equal. Dia tak boleh kalau cesium nak release 1 electron sahaja, dia release 1 electron saja tapi Pb kena gain 2. Okay. So dia tak boleh macam tu. Okay. Sama ada 1 atau 2 ni depends on charge dia nak balance. Okay. So apa yang di-release must begin by another electrode tu. Okay. So sekarang ni dah release, okay, dah gain. So dah cancel out lah. So we just write down balik, okay, the chemical equation tu, okay, plus Pb2 plus. So benda yang sama lah, okay. Sn2 plus Pb. Okay. Sekali dengan dia punya ni lah, okay, aqueous, ni solid. Okay. So selesai dekat situ. Okay. And then okay, kita tengok soalan yang ketiga. Nak bagi ruang dekat sini. Tak nak padam. Okay, soalan yang ketiga dia kata create a galvanic cell diagram to match your equation. Label all the electrode and also electrolyte. So tadi kita tahu dah, okay, cesium ni akan undergo oxidation, so dia duduk kat anode lah. Anode will undergo oxidation. Pb, okay, Pb akan undergo reduction, so dia akan duduk dekat cathode. Okay, so to set up the galvanic cell, as we know that we need to have 2 different beaker ataupun container, okay, to separate between the cell. Okay, so kita akan lukis balik lah, okay. And then we have a salt bridge to maintain the electrical neutrality. So we have electrode, we have the connecting wire, okay, and then we have a voltmeter to measure the voltage produced, okay, and we have an electrolyte there. Okay, so dekat sini anode, okay, kita akan letak Sn, okay, dekat sini cathode akan letak plumbum, okay. So this one is cathode lah. Okay, so dekat sini apa dia punya electrolyte, okay. So Sn2 plus lah, okay, ataupun cesium nitrate ke, sulfate ke, okay. Pb kalau satu nitrate, ni pakai nitrate jugalah. Okay, dia punya liquid ataupun electrolyte. Okay, so complete lah, boleh dikatakan complete lah kita punya tu. And then kita punya movement of an electron. Okay. So this is the example, okay, how to answer the question. Okay. So any question class?
No madam.
Okay. Okay, so the standard cell notation. Okay, so for the standard cell notation, tadi kita tengok, tadi saya beria-ria lukis ni. Okay, so beria-ria saya lukis ni. Okay, so kita tengok pula, okay, macam mana kita nak ringkaskan daripada gambar rajah ni. Okay, so we actually can make it simpler, okay, ataupun kita boleh menterjemahkan, okay. So kita boleh menterjemahkan this diagram, this galvanic cell diagram into a notation ataupun dalam penyataan ataupun dalam penulisan lah, okay. So we use the standard cell notation ataupun line notation kita panggil. So it is a shorthand description of voltaic or galvanic spontaneous cell, okay. So the reaction condition, for example pressure, temperature, concentration, tapi biasanya kita letak concentration je lah, okay, of the anode and cathode, okay, and the electrode component are all described in this unique shorthand, okay. So dia akan bermula dengan anode, okay. So for example kat sini kita tengok anode ni akan duduk dekat bahagian kiri sekali, okay. And then diikuti dengan cathode, okay. So satu palang ni, okay, so single line to represent phase boundaries, okay. Double palang ni is to represent liquid junction, okay. So that's mean when you want to separate between anode and cathode lah, okay. So kita cuba satu nak buat cell notation ni, okay, towards this galvanic cell tadi, okay. So kalau kita tengok side ni anode kita tadi, side ni kita punya cathode. Okay, so now how we are going to construct a cell notation from this this galvanic cell. Okay, so dia kata mula-mula kita akan bermula dengan anode punya electrode. Okay, so Sn solid. Okay, so phase boundary. Okay, maksudnya between electrode and also you punya electrolyte, and then the electrolyte is Sn2 plus ataupun Sn nitrate ke apa. Okay, and then dia dalam bentuk aqueous and the concentration is 1 molar. Okay, so kita nyatakan dekat situ. And then, okay, liquid boundaries between anode and cathode, and then proceed with the cathode solution which is Pb2 plus, aqueous, standard concentration 1 molar, okay, and then Pb solid. Okay, so that's mean, okay, kalau kita membaca daripada cell notation, kita boleh bayangkan dah macam mana galvanic cell kita tu. Okay, or from the galvanic cell kita dah boleh construct dah the line notation ataupun shorthand form of a galvanic diagram ni. Okay, so that is notation lah kita panggil. Okay, so cell notation lah. Okay, okay, so kalau yang ni, okay, so untuk yang ini kalau kita tengok, okay, kalau kita tengok macam ni okay, kadang-kadang student tak tahu, dia tak nampak, okay, that hint. Okay, let's see, dia tak tanya, let's see yang ini dia tak nyatakan. So, siapa anode, siapa cathode? Okay, dia tak cakap. Okay, dia tak ada label anode, cathode kat sini, tak ada. Okay, so macam mana nak tahu ni madam? Okay, so dah bagi hint dah kat sini. So, you see ada electron flow. Okay, so you tengok the electron flow. So, electron flow only have one direction from anode to cathode. So, kalau electron flow dia ke sini, so that's mean this one is anode, this one is cathode lah maksudnya. Okay, so itu je lah dia punya hint dia tu. Okay, so to construct, okay, dia punya dia punya cell notation, cuba you buat satu, nanti saya panggil mana-mana nama yang bertuah. So 1 minit untuk construct. What is the cell notation for this diagram? Okay, so diagram yang ini. So apa cell notation dia? So line notation dia. Okay, so cuba buat. Sekejap Okay, dah siap? Aisyah Noraziah ada? Aisyah Noraziah. Aisyah Noraziah.
Ya, madam.
Dah siap?
Dah.
Type dekat chat box tu.
Dua-dua anode dengan cathode.
Cell notation. Cell notation kenalah ada anode dengan cathode.
Okey.
Ah.
Sekejap.
Cepat sikit. Mana Aisyah? Type je. Type je kat chat box tu. Cepat sikit, ke banyak gini. Aisyah. Kita tengah cakap pasal cell notation. Macam mana nak form cell notation? Itu yang awak buat tu half cell ni. Cell notation ni. Macam mana nak buat ni? Ada kawan boleh tolong dia? Ada kawan boleh tolong Aisyah? Tolong type dekat chat box tu. What is the cell notation for the galvanic cell ni? Magnesium and manganese ni. Ada siapa-siapa boleh tolong? Okay, thank you Yolun. Okay, so yang Aisyah buat ni is a half cell. Okay, so it's a half cell. So yang kita nak sekarang is a cell notation. Okay, so that means a shorthand ataupun notation that represent a galvanic cell lah. Okay. Okay, so for the standard cell potential, okay, itu tadi adalah berkenaan dengan cell notation lah. So kalau cell notation ni tadi, kita akan tengok dia boleh jadi macam-macam. So kalau macam dalam soalan yang sebelum ni tadi, okay, dia bagi equation lah. Okay, and then dia minta you construct a diagram dan sebagainya. Okay, ataupun okay, dia tak bagi dalam bentuk equation, dia akan bagi dalam bentuk cell notation contohnya. So kalau daripada cell notation tu mungkin dia minta half equation ke, and then complete balance equation, and then dia minta cari cell potential. Okay, so macam itulah soalan-soalan yang akan dikembangkan lah. Okay, so next we move to the standard cell potential. Okay, so the standard cell potential is the potential difference between the cathode and also anode. Okay, so maximum potential difference. Okay, ataupun maximum potential difference ataupun maximum cell potential yang terhasil, okay, between electrode anode and also cathode. Okay, so the standard cell potential are measured, okay, 298 Kelvin, 1 atm and with 1 molar solution. Okay, so this is the standard condition lah kita panggil. Okay, so this one is a standard condition. Okay, so standard potential ni yang ini temperature dia, pressure dia, concentration dia kita panggil standard condition dalam keadaan yang standard. Okay, so mungkinlah kalau pergi buat galvanic cell tu dekat apa tu nak measure cell potential tu dekat Gunung Everest ke, dah lain lah dia punya temperature and also pressure, right? Okay, so akan berubah lah dekat situ. So this quantity is related to the tendency for an element or compound or an ion to acquire or gain or release, okay, loss an electron. Okay, so consider the following galvanic cell. Okay, so kalau kita write down the cell potential, cell notation. Okay, so kita akan write down macam ni. Okay, so kalau kita tengok dekat sini 1 molar. So maksudnya merujuk kepada ni electrolyte tu punya kepekatan. Okay, so biasanya dekat dalam practical class, okay, biasanya practical class kita akan buat lah. Let's say kalau yang macam galvanic cell punya eksperimen tu, okay, so galvanic cell punya eksperimen hari tu, okay, sepatutnya kita akan buat tu, okay, zinc kalau kita nak buat solution dia zinc sulfate, okay, SO4, okay. So kita akan prepare solution ni dengan kepekatan 1 molar, okay. So kita akan ni lah, okay, zinc ni dalam bentuk solid, and then kita akan larutkan dengan distilled water, okay, and then kita kena kira dulu berapa zinc sulfate ni punya berat dulu, okay, untuk dapatkan 1 molar solution, okay. And then kita akan gunakan volumetric flask, okay. So that are the procedure yang you miss untuk buat lah, okay, because of online PDP ni, okay. So hopefully nanti semester depan you dapat lah, okay, datang lab and then buat balik prosedur eksperimen yang normal dekat dalam lab, hopefully lah, okay. So kita kena buat, okay. So condition dia 1 molar kepekatan dia, kita kena buat 1 molar. So electrolyte yang ada dekat dalam ni akan ada kepekatan 1 molar, okay. So dia ideal, okay, ideal solution lah, okay. So maksudnya dia ada banyak kepekatan, boleh prepare nak 2 molar ke, 0.5 ke, 0.1 ke, tapi 1 molar is an ideal concentration, okay. So it's referred as a standard condition, okay. So this one, okay. So 1.10 volt ni is the maximum potential value between zinc and copper measured as 1.10 volt. Okay, bila kita ada zinc and also copper as an electrode, okay, so bila kita combinekan dua ni as an electrode anode and also cathode tu, okay, maximum potential between dua electrode ni yang terhasil is 1.10 volt. Okay. So 1.10 volt does the standard cell potential ataupun E0 cell, okay, or standard electromotive forces ataupun EMF for the zinc copper galvanic cell. Okay. So sama ada nak pakai E0 cell ke, okay, atau cell potential ke ataupun EMF, semua ni merujuk pada benda yang sama lah, okay. Okay, so the standard cell potential E0 cell is denoted by degree sign as a superscript, okay. So degree sign of a superscript ni maksudnya E0 ni lah, okay. So E0 and then cell, okay. So it measured against standard hydrogen electrode, okay. So macam saya pernah terang, okay, in our previous experiment punya kelas, okay. So how kita dapat this kind of value ni, okay, yang macam ni, okay, is when we measure with the standard hydrogen electrode, because hydrogen electrode value dia adalah kosong. So kalau kita ada dua sel dekat situ, satu hydrogen, satu lagi apa-apa zinc ke apa, okay, hydrogen ni dah sasah nilai dia 0, so any voltage produced is referring to the other one more electrode ni lah yang hasilkan value-value yang ada ni lah, okay. Okay, and then pressure 180 atm, concentration 1 molar, and temperature 25 degrees Celsius. Okay, so the standard cell potential E0 cell of the galvanic cell can be evaluated from the standard reduction potential of 2 half cell. Okay, so yang kita boleh tengok, okay, standard cell potential ni berdasarkan standard reduction potential yang kita ada nilai dia lah dekat sini. Okay, so daripada sinilah nak tengok untuk oxidation, nak tengok untuk reduction, can refer here, okay. Okay, so from the table, okay, so let's say lah, okay, tak nak cakap banyak-banyak berkenaan dengan table tu sebab hari tu saya dah terangkan dah berkenaan table tu. kita nak tengok macam mana kita nak gunakan table ni lah. Okay. So what is the potential for the cell? Okay, so from the table of standard reduction potential, okay, we have the following value. So dekat sini we have zinc, okay, and we have copper. So zinc at anode undergo oxidation, copper at cathode undergo reduction. So now we want to know what is the maximum potential value between zinc and also copper electrode ni. So maksudnya we want to know what is the voltage produced dekat sini lah by using a calculation. So if we set up this galvanic cell, okay, we can measure according to the voltmeter, okay. But now, okay, we want to calculate, okay, the cell potential, okay. So sometimes kita boleh set up this galvanic cell, tapi mungkinlah dia punya value tu taklah tepat-tepat 1.10 kalau ikutkan, okay. So mungkin akan ada perbezaan sikit lah dekat situ, okay. Okay, sekejap kita kosongkan dulu, kita nak tengok sama-sama from scratch macam mana kita nak kira ni jalan kerja dia lah. Okay. Okay, so kita nak kira dia sekarang. So kita ada, okay, so biasanya okay, kita akan buat dulu lah, okay, dia punya half cell dulu. Okay. So anode, so that means anode dia akan undergo oxidation lah kan. Okay, so zinc, okay, zinc 2 plus 2E. Okay, so saya cepat je, saya dah tak ada lah nak kira satu-satu ke apa. Okay, so kita boleh lah. Okay, tapi mungkin kalau tak biasa kita kena kira lah dulu. Tak adalah main letak je dua ni lah. Okay, kalau ikutkan. Okay, and then copper, okay, 2 plus 2E, and then you get copper. Okay. So now, okay, yang ini akan undergo reduction, ini akan undergo oxidation. Back to our table, standard reduction potential table. Okay, so kita kena ingat, so this is referring to the reduction. Okay, so maksudnya kita boleh ambil bulat-bulat nilai tu for copper saja. Okay, maksudnya E note cell, E note CU lah kita panggil, E note CU. Okay, E note reduction, okay, berapa? Okay, so kita tengok balik dekat kita punya nilai ni, kita cari untuk copper 2 plus. Okay, copper 2 plus ini, so inilah nilai dia. Positif 0.34. Positif 0.34. So E note copper. So maknanya E note E note untuk standard reduction potential untuk copper lah. Okay. And then untuk zinc pula, zinc undergo oxidation. Okay. But this is the standard reduction potential table untuk reduction saja. Okay. So kita tak boleh nak directly guna dia lah. Okay. Tak boleh nak directly guna this kind of value lah. Okay. Tapi kita boleh guna untuk bantu kita dapatkan standard oxidation potential. Okay. So cara dia, kalau untuk cari E star lah kita panggil. Okay. Standard oxidation potential. Formula dia negative E note. Okay. And then berapalah kita kena carilah. Okay, E note untuk zinc tu berapa? Okay, zinc 2 plus. So where is zinc 2 plus? This one. Negative 0.76. So nak dapatkan the value of standard oxidation potential negative 0.76. So positive 0.76. Okay. And then for the formula to find out the cell potential, E note cell, E note reduction plus E star E oxidation of zinc. Okay. So ini 0.34 tambah 0.76. So that's why you dapat 1.10 volt tu lah. Okay. Sama kan? Okay. 1.10 volt. Okay. So when you are writing the final answer, okay, the unit must also be included. Kalau tak, boleh tolak markah lah dekat situ. Okay, tak ada unit dekat situ. Okay, so since kita tahu this galvanic cell always a positive value. Sama ada you letak positive 1.10 volt pun boleh. Kalau tak ada pun okay, boleh lah. Okay, so cumanya voltage tu must be present lah. Okay, okay, so that is how okay, we find out the cell potential, okay, value, okay, for the compound. So kat sini pun dia dah nyatakan juga dia punya cell notation, okay, as a shorthand for the galvanic cell. So dekat sini kalau nak letakkan compound tu sendiri pun liquid ataupun electrolyte tu terus pun boleh jugalah, instead of kita letak ion dia saja. Okay, tak ada masalah. Okay. Okay, so okay, now kita nak tengok what is the potential for the following cell. Okay, so yang ini saya nak minta awak buat. Okay, so semua tolong buat. Buat atas kertas. Okay, buat pengiraan atas kertas and then ambil gambar. Kejap lagi saya akan bagi dekat mana nak kena upload tu. Okay, so boleh mula dulu. Kejap lagi saya bagi link untuk upload jawapan awak. Okay. Boleh mula sekarang. Saya bagi 3 minit cukup lah kot. Yang untuk jadual tu pergilah tengok dekat ni okay. Sendiri punya nota. Pergi download dekat CDOS tu ada. Saya display soalan ni je kat sini. Okay, boleh mula sekarang? Okay, so dekat chat box tu, I already paste the link okay, for you to upload you punya answer. Okay. So, you just ambil je gambar. Okay. Jawapan yang you dah buat tu. Okay. And then you akan pastekan saja gambar tu. You just upload je gambar tu dekat situ. So, tak perlu. Dia boleh juga nak tulis atas tu. Tapi dia lambat lah untuk awak. So, terus je ambil gambar apa yang awak dah buat. Okay. 5 minit lagi. Baru ada 10 orang ni. Mana yang lain? Saya ambil kedatangan melalui ni.
Dah nak siap, madam.
Okay, so yang tengah buat tu tolong siapkan. Okay, saya nak teruskan dulu. Okay. Ke next slide lah. Okay, sekejap Okay, so untuk soalan seterusnya ini, okay, so untuk soalan yang seterusnya ini, sama juga, okay, sama jugalah, okay, you want to calculate the cell potential, okay. So cumanya untuk yang ini, okay, apa yang kita akan buat, apa yang saya nak cakap adalah berkenaan dengan kalau kita tengok dia punya perbezaan charge yang ada kat sini, okay. So saya rasa saya dah explain juga previously dalam previous lesson, okay. But saya nak remind balik lah, okay, kalau ada benda-benda macam ni. So let's say kalau soalan ini, yang ni dia dah minta cari cell potential lah. Tapi saya nak cakap berkenaan dengan complete balance equation dia. Okay, so kalau ini kita tahu sini sebelah anode, ini sebelah cathode. Okay, kalau half equation dia is going to be like this, PB to plus, okay, plus 2E. Okay, because we want to make sure this one ada kosong charge, this one also zero charge. Okay, so same goes with the other side. Fe3 plus, okay, plus 3E, okay, and then Fe. Okay, solid lah. Okay, ni solid. Aqueous, okay. Aqueous, okay, solid. Okay, so this is a half equation. So first half equation, second half equation. But when you want to do a complete balance equation, okay, so you have to take a look. Okay, awak kena tengok yang ni. Okay, sebabnya dekat sini, as you can see, PB is going to release 2 electron. Okay, but iron, okay, iron 3 plus is going to gain 3 electron. Okay, so dia tak sama dekat sini. Okay, so you have to make sure apa yang PB ni release itu juga, that amount juga, okay, will be gained by iron. Okay, so apa yang you kena buat, so you have to make sure you have an equal number of electron that is going to be released, and also equal number of electron that is going to be gained by another one more electrode. Okay, so cara dia, you kena dapatkan satu nilai yang sama. So nak samakan dengan 2 macam tak boleh jugalah. Okay, ni 2 dengan 3 nak sama ke 2 tak boleh, nak samakan ke 3 pun tak boleh. So what you can do is you times by 3 here, and you times by 2 here. Okay, so if you times by 3 here, you are going to get this one. Sekejap Okay, so you akan dapat, so if you time by 3, that mean all the element that you have in the equation needs to be times by 3. So you have 3 PB, okay, 3 PB2 plus, okay, plus 6 electron. Okay, and then same goes to another one more half equation lah. 2 iron 3 plus, okay, plus 6 electron plus 2 iron. Okay, and then when you want to combine it into a complete balance equation, okay, so this one can be cancelled out already lah, because 6 electron that is released and another 6 electron will be gained. So dah release, dah gain, dah habis lah kat situ. Okay, and then you just write down back, okay, the complete balance equation. So yang sebelum arrow ni, okay, so 3PB solid, okay, plus 2Fe 2 plus aqueous, okay, and then after the arrow 3PB 2 plus aqueous plus 2Fe solid. Okay, so ini dah complete balance chemical equation lah. So once you timeskan dia, okay, all the element yang ada needs to be times sama jugalah. Okay, so dekat sini dia akan equal lah nanti. 3PB dekat sini, 3PB2 plus dekat sini, 3PB atom dekat situ juga. Okay, so yang itu saya nak cakap sikit berkenaan dengan balancing half equation dan juga complete balance equation lah. Okay, so calculation of cell potential ni nanti you boleh buat juga sendirilah. Okay, yang ni. Okay, so kita nak summarizekan, okay, apa yang kita dah tengok, okay, untuk kita punya lesson hari ni. Okay, kita akan tengok satu video dekat sini. Okay, so this is the summary. Okay, apa yang kita dah tengok lah untuk lesson kita hari ni.
Professor Dave here. Let's talk about electrochemistry.
He knows a lot about the science stuff. Professor Dave explains.
This should be a familiar object to everyone. But how do batteries work? The first one was invented by Alessandro Volta in 1800, and the chemistry hasn't changed too much since then. The chemistry occurring in a voltaic cell is just a spontaneous oxidation-reduction reaction, which we now know is a transfer of electrons. The only difference is that the oxidation and reduction half reactions are physically separated from one another. The anode is where the oxidation takes place, and the cathode is where the reduction takes place. Electrons captured in the oxidation then flow from the anode to the cathode, which generates a current of electrical energy, which can be harvested to do work. Each side of the cell is called a half cell, and they contain ions in solution. There is also something called a salt bridge, from which ions flow to maintain charge balance. At the anode, neutral zinc atoms give up 2 electrons to become zinc ions, which then fall off the electrode into solution. At the cathode, copper ions in solution near the electrode gain 2 electrons to neutralize and join the copper lattice. Ions in the salt bridge compensate for this gradual change in overall charge. A voltaic or galvanic cell is one example of a kind of electrochemical cell in which a spontaneous oxidation-reduction reaction generates an electric current. In an electrolytic cell, an electric current drives an otherwise non-spontaneous reaction. When we describe the components of a voltaic cell, we have to use a particular notation. We list the oxidation half cell, or the anode, on the left, and the reduction half cell, or the cathode, on the right. The double vertical lines represent the salt bridge that separates the half cells, and single vertical lines represent phase boundaries, like between a solid electrode and the ions in solution. We can go between this electrochemical notation and the balanced cell reaction by just including the number of electrons involved in each half reaction. Then use the least common multiple of electrons to combine the half reactions into the cell reaction, and electrons will cancel. Let's try to understand the concept of electron flow. Just as water flows from high pressure to low pressure, electrons flow from areas of high to low electric potential. So electric potential is kind of like electric pressure. Potential difference is the difference in electric potential between 2 points. In the case of a voltaic cell, those points would be the anode and the cathode, and their potential difference is called the cell potential, or E cell. This will be expressed in volts. For a voltaic cell, we measure the cell potential by looking at the oxidation potential and the reduction potential. But since oxidation and reduction are reverse processes, these will simply be the opposite of each other. So we arbitrarily decided to tabulate reduction potentials, and the E cell for a voltaic cell will be E cathode minus E anode, because we are measuring the reduction that happens at the cathode and then adding the reduction that could happen at the anode, but reversing the sign because it is actually oxidation that is taking place. So we have a whole list of reduction potentials, and these numbers tell us how favorable it is for a substance to be reduced. We can see here that fluorine is a very good oxidizing agent, as it has a high reduction potential, which makes sense since fluorine has a very high electron affinity. On the other end, elements like lithium and sodium have very negative reduction potentials, making them good reducing agents, since they have a tendency to be oxidized, as it is more favorable for them to lose an electron than to gain one. To calculate E cell for any hypothetical voltaic cell containing 2 of these substances, just calculate E cathode minus E anode. The larger the E cell value, the greater the current the cell will generate. The change in Gibbs free energy for the cell can be related to the cell potential. This is the maximum work a voltaic cell is capable of. Here, N is the moles of electrons exchanged in the reaction, and F is the Faraday constant, the electric charge of a mole of electrons. We can also relate cell potential to its standard cell potential under standard conditions by using the Nernst equation. Here, Q is the reaction quotient. Let's check comprehension.
Okay, so yang tadi ni dia ada cakap berkenaan dengan cell potential ni tadi. Mana tadi? Yang ni, okay. So sama jugalah, okay. Kalau dalam persamaan tu instead of you nyatakan sebagai apa ni? This one, sekejap Yang saya ajar tu kita akan buat E node cell plus E oxidation plus E reduction, okay. Tapi kalau gunakan yang ini pun lebih sama juga sebab kita akan negatifkan value of E node reduction tu, okay. So E node reduction tu. Tapi yang apa tu, yang akan cathode tu yang akan duduk depan, okay. E cathode minus E anode, okay. So kalau yang E node cell, E node plus E star tu, okay, mungkinlah bolehlah tukar-tukar kan, sebab memang you akan buat jalan kerja untuk positif ataupun negatifkan value of standard reduction potential tu, okay. So ini pun boleh diterima jugalah, okay, boleh je lah, tak ada masalah. Cuma yang next ni yang yang Nernst equation, Faraday constant ni semua kita tak ada lah, kita tak ada tengok yang ni lah, okay. Okay, so that is for the conclusion. Okay, so basically kita dah habis dah untuk this ni lah, okay, this chapter. Okay, so any question? Ada soalan? So kita dah habis untuk acid base, okay, untuk electrochemistry. Okay, for the physical part, basically kita dah finishkan dah, okay, kita dah habiskan. So next kita akan masuk untuk part organic chemistry pula. Okay. So kita dah nak bye-bye dah, okay, chapter ni. And then nanti kita akan ada quiz lah. Saya rasa minggu depan kot. Okay, mungkin minggu depan kita akan buat quiz dan saya akan beritahu bila. Okay, untuk quiz 1, chapter electrochemistry and also acid base. Kita akan tengok 2 chapter ni untuk quiz pertama. Saya akan beritahu. Okay. And then kita akan ada end of chapter juga untuk yang ini. Okay, so next, okay, apa yang saya nak minta awak buat? Saya nak completekan yang ni, okay, soalan learning check ini, okay. So tengok okay, you nak kena write out oxidation and reduction half equation, kena sertakan half equation and write down the complete balance chemical equation. So dekat sini you tengok nanti adakah bilangan elektron yang akan di-gain ataupun di-release tu. Ya?
Kita nampak screen YouTube je.
Oh, okay, jap. Okay, so okay, selepas ini saya nak minta awak buat yang ni, okay, learning check yang ini, okay. So yang ini dia punya galvanic cell lah, okay. And then apa soalan pertama, you need to write down half equation for both oxidation and also reduction punya half equation, and then complete balance chemical equation. So dekat sini nanti you kena make sure lah, okay, how much electron that is going to be released, okay, sama tak dengan electron yang akan di-gain tu, okay. So macam yang saya tunjuk contoh tadi tu lah, okay. So yang release tu tak sama dengan gain berapa. Release 2, nak gain 3. So nak buat apa untuk samakan elektron tu? Mesti sama, okay. Release electron and also electron that is going to be gain. Okay, and then after that you kena write down, okay, cell notation daripada ini, from this one, okay, from the galvanic cell, and calculate the cell potential, okay, berapa E node cell dia, okay. So kena cari E node reduction and also E star untuk oxidation. Okay. So yang ini nanti you akan ni lah letak dekat new pot saya. Okay, sekejap saya bagi link dia. Tak ada masa lagi ni. Kita akan completekan soalan ni sama macam tadi juga. Kita akan upkan dia dekat new pot tu. Sekejap saya bagi link. Okay, so ada link kat situ. Okay, so boleh mula menjawab sekarang sama macam tadi. You buat, okay, and then you akan upload lah dekat Nearpod. Yang ni, yang tadi ada 23 orang je. Syahira Izani mana?
Saya madam.
Awak punya mana?
Saya
Yang
dah
soalan tadi. Tak ada pun. Hang. Okay, so boleh buat yang ni. Soalan yang ni. Soalan ni saya ambil sebagai attendance awak So kena buat. Okay, so nanti boleh upload dekat situ. Okay, so bila dah upload, bila dah settle upload and then you boleh left the session lah. That's all for today lah. So see you next week. Thank you. Ada 23 orang submit ni. Battery Shelburne tak ada.
Madam, my one I opened 2 tabs, so I already submitted below Tan Yulun. My one already submitted. I accidentally opened 2 tabs.
Okay. Okay, so ada 22 orang je lah yang submit ni. Okay. So tak ada yang tak submit ke? Saya nak kira attendance ni.
Madam, saya dah hantar tapi tak dapat.
Tadi line Syazah madam. Tadi line saya slow sangat.
InsyaAllah.